Okay, here we go. We're on 3C.1, the quadratic formula. Today we're going to sing, guys. Are you ready to sing with me? Hopefully. Yeah. Make sure your voices are ready. Okay. All right. So our goal today is to solve a quadratic equation using the quadratic formula. And we're going to solve problems that can be modeled by quadratic equations. So do you guys remember how when we were factoring, there were certain problems that we couldn't factor, right? And we just called them prime. Well, when that happens, that means that there has to be another way to solve that problem. Does that make sense? Factoring may be prime, but the solution is not necessarily undefined. Does that make sense? So what today is focusing on how to solve. So we've learned in the past in this section, well, in this course and in Algebra 1, that the quadratic equation is an equation written in the form of ax squared plus bx plus c equals 0. Okay. In order to solve a quadratic equation, it has to be equal to 0. So one side has to be equal to 0. It really doesn't matter which one, but one side needs to be equal to 0. The other thing about the quadratic equation is that I personally like to make sure that my a term is positive. So if I have to subtract, I'm going to move to make sure that my leading term stays positive. Does that make sense? Okay. The other thing that we want to make sure that if there's a GCF, that we factor out that GCF. So anytime there's a GCF, we want to say, okay, I want to make this as simple as possible for me to manipulate. Got it? All right. So let's keep this show on the road. All right. This is what we call a second degree equation, a second degree polynomial. This is our polynomial unit. It's called a second degree polynomial because look at the x. What is the highest power on your variable? 2, which is why a quadratic is called a second degree polynomial. You hear me, sonny boy? That's what you feel like you're doing it. Okay. All right. So again, this is our second degree polynomial. A linear is called a first degree polynomial. That's because the power on the variable is a 1. Does that make sense? Okay. All right. So we're going to keep this show on the road. Now, when we have a quadratic equation, we're going to use the quadratic formula. The quadratic formula is used when you cannot solve by factoring. Okay. So when we can't solve by factoring, we use the quadratic formula. Does that make sense? The quadratic formula tells us a couple of things. What's inside the quadratic formula, that's called our discriminant. So that b squared minus 4ac, if that is less than 0, that means you have no real solution, meaning that if it's negative. So if I'm less than 0, that means I am a negative number. And if I am negative, then I have no real solution. We'll learn about those later. If I am greater than or equal to 0, that means I have 2 real solutions. Well, at least 2 real solutions. At most, I'm sorry. At most is the word. Okay. If I'm greater, that means I'm positive or equal to. All right. Now, remember I said we got to clear up ourselves to sing? Stand up. I'm gonna make y'all do what my Algebra 1 teacher made us do. Everyone stop, put down pencils, and you're going to stand up. Stretch your arms a little bit. How many of you know the song Row, Row, Row Your Boat? Do we know row, 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 row your boat gently down the stream? Merrily, 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 life is but a dream, right? Yes? Okay. We're going to keep that tune in our head as we learn the quadratic formula. All right, here we go. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Hey, okay? All right. That's the song they're singing. That's the quadratic formula. So you see on the board right here, this is the quadratic formula. This is the formula you should memorize. Okay. All right, here we go. X, you guys say it with me. It helps you with in the arms. You have to do the arms. I don't know what it is, but I've been doing this since 8th grade. It just goes with it. Okay. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Hey. Okay, just keep rowing. You're rowing your boat. I really don't know how to row a boat, so I don't know the motions your arms are supposed to make. But we're just gonna keep doing what I'm doing because that's how I'm pretending to row my math boat. Okay, but this is our formula. Say it with me. Here we go. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Hey, okay, that is the quadratic formula. All right. This is your catch-all. If you are terrible at factoring to solve, this is your friend. Okay, what this does is that someone realized that if I plug these variables into a certain location, I can solve without having to factor. Okay. Or if I have a prime factor, this is how I can solve that problem. All right. By using this formula. Capiche? All right. So this is our new friend, the quadratic formula. Got it? All right. You can have a seat. So now let's use the quadratic formula. Okay. How do we use the quadratic formula? First, you're going to identify your A term, your B term, and your C term. Okay. You're only using their coefficients. All right. So your A is going to be whatever this is. It's with your x squared. Even if they're not in order, your A is always going to be with your x squared. Your B is going to always be with your x, and your C is the loner. Okay. Step 2 is you're going to decide, is it going to be a real solution or not? So you're going to do the inside first, which is b squared minus 4ac. Okay. Your b squared minus 4ac, you're trying to see, is it positive, negative, or equal to 0? Okay. If it's negative, there's no real solution for us right now. Well, there's no real solution ever, but we're not worried about it. We just get to stop the problem. Okay. If the discriminant is 0, there is one real solution, and we're going to find it. That's what we call a double root. If it's positive, then there's 2 distinct real solutions. That means I have 2 numbers that work. Now, if you are a strong factorer and you're like, I like factoring, if you can easily spot the factors, then continue to factor. Okay? If factoring is not your strong suit, then the quadratic formula is your friend. Got it? But if you're great at factoring, guess what you should do? Factor when possible. If you're not, then here's our friend. All right? Your discriminant. Again, your b squared minus 4ac, that is called our discriminant. And we start with the discriminant because it lets us know how far we have to go in our work. Does that make sense? Okay. All right. So are we ready to do it for the first time? All right. Here's our problem. We have 3x squared minus 4x minus 1. Okay. And we're going to, first step is to identify our a coefficient, our b coefficient, and our constant. Our a coefficient is always with our x squared. So we know a equals 3. Your b is going to always be with your x. So our b equals -4. And your c is your constant. It's a loner. It has no variable, which in this case is -1. Okay. And we're going to plug them into the quadratic formula. All right. So again, I'm going to sing it and we're going to write it out so we can get used to it. X equals -b plus or minus the square root of b squared minus 4ac divided by 2a. Okay. And now we're going to go through and plug in where everything is. So we're going to plug in where a is. That's where we're going to put a 3. Okay. Where b is, that's where we're putting in our -4. And where c is, that's where we're putting in our -1. That's the beauty of a formula, is your job now is just to plug and simplify. Does that make sense? All right, so now we're going to go through and plug everything in. So if x equals -b plus or minus the square root of b squared minus 4ac divided by 2a. So notice I plugged in everything where they go. Okay. The next step is to do your, so we're done with step 1. Step 2 is to solve what's underneath the square root. Okay. So we're going to solve what's underneath the square root, which is our b squared minus 4ac. So we're going to simplify this first. Does that make sense? It's like parentheses. You do what's inside the parentheses or the grouping first. So we're going to simplify that first. So we're doing -4 squared minus 4 times 3 times -1 equals a negative times a negative is a positive. -4 times 3 is -12 times -1 is positive 12. 16 plus 12 is going to give us 28. So we have a real solution. So we know that we should have 2 answers. And now we're going to take that and plug it back in. Okay. Are we good with step 2? Yeah. So now into step 3, we're going to plug back in. A negative times a negative here is going to make a positive. 4 plus or minus. And now what's underneath our square root? What did we get? 28. All over. And what's 2 times 3? 6. Okay. So this is our unsimplified answer. Okay. It's unsimplified because I have not simplified the radical. When you have a radical, a square root, you're asking yourself, is there a perfect square that makes this number? So 28 is made up of what? What makes 28? 4 and 7, 2 and 14. 4 and 7 makes 28. That means that this is made up of a perfect square. So we have the square root of 4 and the square root of 7, because 4 times 7 makes 28. Does that make sense? Okay. We can take the square root of 4. What is the square root of 4? 2. Can we take the square root of 7? No. So it gets to stay inside. That's an ugly 6. Hopefully that made it a little better. Okay. And now our job is to create our 2 separate solutions. Uh-oh. I skipped a page. Go back. Go back. Go back. How did I get all... Oh my God. What are you doing? I was going to cry in about 2 seconds if all that writing was gone. Okay. This plus or minus that you see right here, this guy means that you're going to have a positive plus and a minus situation. So we have 4 plus 2 square root of 7 over 6. And we're going to have 4 minus 2 square root of 7 over 6. That's what that plus or minus means. Does that make sense? And now at this point, your job is just to simplify the things outside the radical if they can be simplified. So when I look at 4, 2, and 6, do they have a common factor? Does 4, 2, and 6 have a common factor? 2. That means I can divide everything by 2. I can divide each one of these by 2, divide each one of these by 2, divide each one of these by 2. And that's going to give me my final answer. So we end up with x equals, what's 4 divided by 2? 2 plus 2 divided by 2 is 1. Is it necessary for me to write 1? And that gives us 6 divided by 2 is 3. So that's our first solution. Our second solution is going to be the same thing, but instead of plus, it's a minus. And these are your exact solutions. So when it asks for your exact solution, this is what they're looking for. You will not get the exact solution in Desmos. Desmos is going to give you the approximate decimal value. Does that make sense? You can always work backwards from there, but Desmos is not going to give you your exact solution. Okay, so a lot of math took place here. Let's recap what we did. First, we identified our variables, right? Our coefficients and our constant. We plugged them in. Second, we did our discriminant. Once we figured out our discriminant, we figured out that it's positive. And so therefore we should have 2 real answers. Got it? Then we plugged our discriminant back in and we simplified it. If I have square root of 28, 28 is made up of square root of 4 and square root of 7. The square root of 4 is 2 and the square root of 7 is nothing because it is a prime. That plus or minus tells me I have 2 solutions, which confirms step number 2. I have a positive and a negative. And then I just simplify what's outside of the radical. Okay? And what's left, that is your answer. Okay? This is an example of what happens when something isn't factorable. There's no way that I could have factored this to solve it. Because this is the kind of answer that it would produce. Okay? All right, let's try it again. All right. So notice that this time we're not in what form? Is this equal to 0? No, it is not in standard form. So before I do anything, I have to make one side equal to 0. So what do I need to do to make this equal to 0? I need to add 3. So I'm going to add 3 to both sides, and we're going to be left with 5x squared minus 2x plus 3 equals 0. Therefore, I know that 5 is my A, negative 2 is my B, and 3 is my C. So I'm ready to go with step 1 with plugging everything into the quadratic formula. Are we ready? X equals negative B plus or minus the square root of B squared minus 4AC divided by 2A. So as I set the variables, I put them in the place that they go. Are we good with step 1? Yeah? Okay, step 2 is we then simplify the what? What do you remember what's called underneath the square root? Starts with the D, discriminant. The discriminant. Remember, that's called the discriminant. So we're going to simplify our discriminant. So our discriminant is negative 2 squared minus 4 times 5 times 3. A negative times a negative is a positive. Negative 4 times 5 is negative 4 times 5 is negative 20 times 3 is negative 60. 4 minus 60 equals what kind of 56? Negative 56. Oh no. Our discriminant is negative. What does it mean if you look back on your notes when your discriminant is negative? What does it say? No real solution. So guess what we get to do? We're done. The answer is no real solution. And why is there no real solution? Because our discriminant is negative. And that's where we stop at. Do you see why we check the discriminant? So if we check the discriminant, we can minimize the amount of work we may have to do. And so this problem is done. We can't go any further. Got it? Questions, comments, concern? Still with me? Okay. All right. Let's talk about fractions. A lot of times we freak out when we see fractions, right? The thing is, you can actually get rid of fractions. All right. So when we look up at this problem, we have 7 minus 4 over x minus 5 over x squared equals 0. You're like, oh no, it's a fraction. We're in trouble. Well, we're not. We're going to remove the fractions. Okay. How to remove the fractions? Well, we remove the fractions by multiplying by our LCD. Do y'all remember the term LCD? Does that ring a bell? Least common denominator. Do y'all remember that? So back in elementary in 6th grade, you should have talked about the least common denominator. The least common denominator is what is the smallest number you can multiply everything by, smallest number that you can equally divide your denominators by, right? Divide your denominators into. So for this problem, our LCD would be x squared. Does that make sense? Because I can multiply x times x to get to x squared, and x squared times 1 is going to give me x squared. So our LCD is x squared. So we're going to multiply every single term by x squared. That's how we change this from a fraction to a non-fraction, is by multiplying every single term by x squared. So what that would look like is we would have 7 So we have 7 times x squared. And then we have minus 4 over x. And this is going to be times x squared. And then we have minus 5 over x squared. And then this is going to be times x squared. And this equals 0. And then this is also times x squared. Because I multiply everything by that LCD, it balanced the equation. The equation is still balanced. Does that make sense? Okay. And now we clean it up. So before we can do anything, we have to get this out of fraction form. So 7 times x squared is just going to be what? 7x squared, right? Negative 4 over x times x squared. Well, that eliminates one of my x's, right? And I'm just left with 4x. I have an x squared in the numerator and an x squared in the denominator. What happens? They cancel out, and I'm left with minus 5. And anything times 0 is still going to be 0. So we went from a fraction to a non-fraction by using our LCD. See that with me? All right, now can I proceed with the quadratic formula? Yeah, so now we can go through our quadratic formula steps. So step 1 is to identify your A, your B, your C, and to plug it into the quadratic formula. So our A is 7, our B is negative 4, and our C is negative 5. So we have x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. After that, we then, what is step 2 to do? We check what is this called? Discriminant. I really don't know how to spell it. I'm just going to stop right there. I don't know what happens at the end. Okay. So we're going to check our discriminant. So on our discriminant, we have negative 4 squared minus 4 times 7 times negative 5. And we want to figure out that a negative times a negative is a positive. So that gives us positive 16. Negative 4 times negative 5 is positive 20. 20 times 7 is 140. So we're left with 156. Are we good? Negative 4 times negative 5 is what? 20. 20 times 7 is 140, right? So that's how we end up with 140. Because it's a positive number, we know that we actually have 2 real solutions. So we are going to proceed with plugging it back in and solving. I'm going to give myself another page because I'm running out of room to write. So we're going to add on a slide so that Ms. Jones can continue her problem. Okay, so you guys are going to have to remind me what to write because I got to trim me on over here to a blank page. So now we're at step 3, plugging things in. So step 3, I have a negative times a negative is a positive. So we have positive 4 on the outside plus or minus the square root of 156 on the inside, correct? All over what? 14. All right, how many of you struggle with finding numbers that multiply to make something? It's okay if you do. Like, A-okay. So 156, if you struggle with trying to figure out what multiplies to produce something, did you guys learn a factor tree? Y'all remember doing factor trees in 5th or 6th grade? It's the basic way to break down a number. So for example, all even numbers are divisible by 2, correct? So if I divide this into 2, did y'all learn shorthand division in elementary? Okay, let's try it out loud. So 2 goes into 1. Does 2 go into 1? No. Does 2 go into 15? Yes. How many times? 7 with what left over? 1. That 1's going to go right there. That's 16. 2 goes into 16 how many times? 8. So 156 divided by 2 is 78. Okay, that's shorthand division. Did we do it? Yes. Why people didn't teach you? I don't know. Okay. All right. So let's try this again. Now we're down to 78. 78 is also divisible by 2, right? So 78 is divisible by 2. 2 goes into 7 how many times? How much left over? 1. 2 goes into 18 how many times? 9 times. Now 39 is divisible by what? What's the smallest number we start off with? 3, correct? 3 goes into 3 how many times? 3 goes into 9 how many times? 13. So we've just now broken down 156. So your factors of 156 are 2, 2, 3, and 13. Okay. And any multiples, any way you multiply these numbers together produces the other factors of 156. So for example, if I multiply 2 times 2, that's 4. 3 times 3 is 13. So I know that 4 times 39. 4 times 39 is 156. Does that make sense? Okay. Now, not your fault that your number sense and foundational math patterns were disturbed or just not created. Anyways, but 156 can be broken down. When you're looking for square roots, you're looking for pairs of primes. So when I'm looking for my square root of 156, I have a pair of 2's that break down, which is why it's 4 times 39. And the square root of 4 is what? 2. So we know that 156 can be broken down to 4 plus or minus 2, because I have a pair of 2's. And then what's left on the inside? 3 and 13. 3 times 13 is 39. So 156 breaks down to be 2 times the square root of 39. You do not have to be like super genius. You just start at the bottom of your primes, 2, 3, 5s, and divide your way till you can't anymore. Okay? All over 14. When I look on the outside, I have 4, 2, and 14. 4, 2, and 14 have what common factor? 4, 2, and 14. 2. All of them are divisible by 2. So I'm going to divide each one of these by 2. So I'm left with 2 plus or minus 1, which can become Casper the Friendly Ghost, all over 7. So your answers are 2 plus the square root of 39 over 7 and 2 minus the square root of 39, bless you, over 7. And those are our exact answers. So when you're trying to figure out how to break down a number, the way to remember is when you break down the number, if it's a pair, they get to go on a date. If it's not, they stay inside. Okay, so we had a pair of 2's, they get to go on a date. The other 2, womp womp. Another teacher correlated it to being socks. You know how when you're pairing socks together, you're looking for matching socks. When you pair the socks together, you bundle up, and that's 1, right? That's why it becomes just a 2 on the outside. And then the other socks just stay in that drawer because you couldn't find their matches. They just magically disappeared. Okay. All right. Up next is a word problem because you got to tie it back into geometry or something before. So we have a box here. From each corner of a square piece of sheet metal, remove a square of side 5 meters, then turn up the edges to form an open box. If the box hole is to hold 1,125 cubic meters, what would be the dimensions of the piece of sheet metal? Okay, so we're taking this metal and we're cutting it to create a box, basically a baking pan, right? So we're going to turn this into a baking pan. So when we cut this sheet of metal, it's asking, how do you figure out how long the box was originally? Well, in order to figure that out, we know that it's cubic meters. It's total cubic meters, which means that if I'm talking about cubic meters, that is volume. Do you guys remember that from geometry? Anytime you're talking about cubic anything, that means you're referring to the volume. Yes? Rings a bell? If I'm looking for the volume of a cubic function, volume is your length times your width times your height. So for this problem, we know that the length times the width times the height equals 1,125. So we have 1,125 equals your length So your length here is x minus 10. Your width here is x minus 10, and your height is 5. So we have x minus 10 times x minus 10 times 5. Okay, it says, what should the dimensions of the sheet of metal be? Well, in order to solve this, it has to be in standard form. Are we currently in standard form? No, we are currently not in standard form. So we're going to go through and distribute, combine like terms, and get this into standard form. So the first thing we're going to do is FOIL. Do we see where we're going to FOIL? 2, 2, 2, 2. Are y'all with me on FOILing? Okay, so we get 1,125 equals x squared minus 10x minus 10x plus 100. And all of this is still times 5. Still with me? All right, so we can clean up the inside here. What combines? The 210. We also, if we don't want to have a large number, instead of multiplying everything by 5, we can divide everything by 5 and reduce our number sizes. So instead of us multiplying and making super large numbers, we can divide by 5 because the opposite of multiplication is what? Division. All right, let's try our shortcut division. Are you ready? 5 goes into 1. Yes or no? 5 goes into 11. Yes. How many times? With how much left over? 5 goes into 12. Yes. How much? How much left over? 5 goes into 25. How much? 5. So therefore, 1,125 divided by 5 is 225. And that equals x squared minus 20x plus 100. Still with me? All right. Now, this side is still not equal to 0. So what do I need to do to that 225? I got to subtract it. So minus 225 minus 225. So we now have 0 equals x squared minus 20x minus 125. Now, at this point, if you are terrible at factoring, then you could proceed to the quadratic formula. If you're not terrible at factoring, here you can factor. Okay? If you're terrible at factoring, your A is 1, your B is negative 20, your C is negative 125, and you do the quadratic formula. Or you're like, hey, I can factor this. I can ask myself what multiplies to give me negative 125, but adds to give me negative 20. And those two factors are, oh, not that. Anybody? Anybody knows what they are? What multiplies to give me negative 125, but adds to give me negative 20? Negative 5 and switch it. Negative 25 and a positive 5. So negative 25 times 5 is negative 125. Negative 25 plus 5 is negative 20. And that's what this factors out. So our solutions are x equals 25 and x equals negative 5. Which one of these can be a measurement? Okay, you have a negative measurement? No. So the answer is 25. So we know that x equals 25. And because x equals 25, that means the length of your length and your width have to be what? What's 25 minus 10? 15. Does that make sense? So the length and the width of your box would be 15. So the box measurements are 15 by 15 by 5. And that concludes our lesson. That took way longer than I anticipated, but it's okay. We have 30 minutes left.